Clap.
Going to do the discussion about the summarized presentation about statistics. So first question is, what is statistics? By definition, it is the science of conducting studies to collect, organize, summarize, analyze, and draw conclusions from data. So we're going to use this simple definition of statistics in order to picture out the statistics. So by explaining it one by one each term. Shall we start with the collection of data? So as you can see, the most ingredient of doing statistics is the collection of data. So first, what is collection of data? Refers of data gathering using one or combination of the following method. So we're going to highlight the first two methods, and these are interview and questionnaire. Later, if you're going to do your individual research, which you have a prior knowledge during your senior grade 12 requirement of doing the group thesis, I know you're very familiar with this. You are going to do a research work. And the research work can be classified into two types, and these are qualitative and quantitative. Since my subject is mathematics, we're going to focus on the quantitative part. So here, the interview, or what we call the person-to-person exchange, or the direct method, as part of the collection of data, is very appropriate to use in qualitative research. While the use of survey questionnaire is very good to use when your research is about quantitative. It's considered as a cheaper method in collecting data since the researcher will hand it or mail it to the respondents. And the respondents just simply answer all the necessary questions or information with the given prepared survey questionnaire. So again, questionnaire is good for quantitative research, while the interview is good for the qualitative research. Okay, now, the most common problem encountered by the researcher is on how to determine the number of sample size of a given data. So that is why we need to consider this kind of formula. I know some of you are very familiar with this, and this is what we call Slovens Formula, defined as n equals capital N over 1 plus n times e to the power of 2. So when we say capital N, this is refers to the total number of population. How about letter E? E means the margin of error. In doing a research, there are numbers which can be referred as our margin of error, ranging from 1% to 10%. So we're going to use 1% if your research is about medical, is about the effectiveness of the vaccine or any medicine. So in short, the non-precision level is 1%, while the precision level is 99%. So that is why it's very important to use the 1% on the medical or any medicine research. While if the research is about educational purposes or benefits only, we can use the margin of error between 1% to 10%. Let us have an example. As you can see, we have 1,600 senior high school students enrolled this semester. Let us just assume it. Okay, if a researcher will take all the 1,600, this is actually an impractical and not wise decision making by the researcher. So therefore, we're going to reduce it in such a way, we're going to use the Slovens formula in a standard and systematic way. How? So let us bring down the formula. We know that the total number of senior high school students is 16. So we're going to substitute the letter N. How about the letter E? So we can, since it is not about medical or any medicine topic, so we're going to use the 5%. So substitution, we have now 1,600 over 1 plus 1,600 times 0.05 square. Okay, now, what do you mean by letter N? Again, N is a sample size. That is the desired sample size that you would like to have in order for you to have a practical type of research. Since we know 1,600 number of respondents are very huge in terms of respondents. So if you're going to take it all, probably you will spend much of your money and time as well as your efforts. So using your calculator, we will have now the denominators as 1 plus 4. Then we know when we add 4 to 1, we have 5. Then 1,600 divided by 5 is 320 senior high school student would be our desired samples. So from 1,600, we able to reduce it 320 senior high school students. So which is far minimal expenses that you're going to have. However, for some researchers, these 320 senior high school students are still huge. That is why we're going to apply another method. And this is what we call the sampling technique. Okay, there are two types of sampling techniques, guys. We call it as random probability and non-random probability. So when we say random, there is no bias. Otherwise, there is bias in non-random. When we say random, every respondents or every data has the chance to be chosen or to be selected. Otherwise, it is non-random. So let us have now enumerated the different examples for the random and probability and a non-random or non-probability. Okay, so under the random, we have SRS or the simple random sampling. We have lottery, table of random number, and use of calculator. So assuming that we have 320 senior high school students and we want to get 100 as our desired sample size. Using the lottery, your teacher or the researcher will apply this method by asking the respondents to put their name in a one each sheet of paper, each put inside the box, shake it, and randomly pick till it will reach the 100 respondents. So that is what we call lottery. If the researcher used the appendix of any book at the back of the book by determining the different numbers there and use it as part of the sampling technique, we call it as table of random number. For example, in the appendix, there is a number of 0, 1, 2. The 12 it will be the 12 in the list will be part of the respondent until it will reach the desired number of 100 respondents. How about the use of calculator? If you're going to see your calculator, there is a labeled run function, run. Just press the run and it will give you 3 digits after the decimal randomly. So if ever the result is 0.192, which means the 192nd on the list will be part of your respondent. Another example is 0.013. The 30th, 013 means 30th, the 30th from the list will be part of your respondent. However, if you press the run and the result is 0.321, since the total number of senior high school students is 321, you just simply skip it and press the run again. So press it the run again, and then if ever the result is 0.318, then the 318th on the list will be part of your respondent until it will reach the desired number of 100. So that is the use of calculator, table of random numbers, and the lottery method, which is part of the SRS or simple random sampling. So the other four random sampling technique are believed is coming from the idea of SRS. So what do you mean by systematic? We have capital N, small n. Our total number of respondents is 320. Our desired number is 100. Simply divide it. So 320 divided by 100 is 3.2. And since there is no such 3.2 person, so we're going to round it up to the nearest tens. So that is 3. So every 3 or every third on the list of the given senior high school student will be part of your respondent. Example, 1, 2, 3, the third, the 6th, the 9th, the 12th, the 15th, the 18th, the 21st, the 24th, the 27th, the 30th, until it will reach the desired number of 100. That is what we call systematic. Next, stratified. You're going to regroup or group your respondents according to their classification. In this case, senior high school student can be classified according to their strand. So we know we have 5 strands, namely ABM, STEM, UMS, GAS, or TVL. So to do the equal allocation, you're going to divide each strands will be distributed equally. Example, there should be 20 for ABM, 20 for STEM, 20 for UMS, 20 for TVL, and 20 for CAS to get the desired number of 100. How about proportionate allocation? We know that the distribution of the respondents are not that equal. Example, we cannot tell that the number of ABM from 320 is equal to the other strands such as the gas, UMS, TBL, and the STEM. So let us assume there are 120 ABM from that 320 senior high school student. So what you're going to do is this: 120 divide 320, then multiply it to 100. So using our calculator, press 120 divided into 320. Then after that, multiply to 100. The result is 37.5. Rounded up to the nearest 10, so we have now 38. In short, you will only get 38 from that 120. Let's say we have STEM, which is 80. Okay, so 80 divided by 320, then multiply it to 100, and that is 25. So you're going to get 25 respondents from 80 STEM. Okay, that is the use of the stratified proportionate allocation. So you're going to do the same process to the other strands. If the stratified, we're going to group the senior high school student according to strands. In cluster, we're going to group them in a little groups, and that is by section. So section of Galilee and so on and so forth. Next, how about multi-stage sampling technique? If you're going to combine at least two from the previous sampling technique, such as we're going to apply lottery, then after that systematic, we call it as multi-stage sampling technique. So next is the non-random or non-probability. So that is bias. When we say purposive sampling technique, if the research is about the effect of early pregnancy, therefore your respondent must undergone the early pregnancy, probably the girls. You must disregard the boys and those girls who are not yet experienced the early pregnancy. How about the quota? Example, you want to know the effect of using gadgets on our online class, especially the use of laptop. So since most of the students right now are using different gadgets, in quota, you just simply consider those respondents who use at least a laptop. So if they're using only cell phone, then they are not part or qualified for your respondents. But if they are using laptop the same time cell phone and tablet, they are qualified. So in short, that is quota. You just restrict the number of respondents according to their qualification. Next, convenience sampling technique. If you're going to do the research about the perception of senior high school student on the online class and you hire the student from NDMC, you should start and conduct the research within the campus. You don't need to extend some effort and doing that research on the other schools. So you're going to do the research within your range. Okay, snowball. This snowball sampling technique is being used when the case or the research or the phenomenon that you choose as part of your research title is very sensitive, it's very confidential. What do I mean? Example, your research is about the coping mechanism of the drug users. So that is very sensitive, that is very intriguing, and that is need to be kept with confidentiality. So in order for you to get the number of respondents, you're going to ask a legit agency, or you're going to ask from the guidance and so on and so forth, who are capable, who are authorized to give the number of respondents. Otherwise, there will be a problem later if you're going to choose from different person and there will be possible leakage, and that will cause some problems. Okay, so that is snowball. So as you can see, we have 320 senior students after we do the Slovens formula. And since as a researcher, we need to do it economically so that we can at least expend minimal amount in doing the research. So it's very good for us to use the random or non-random sampling technique. But most likely in the thesis writing that are asked to you to do later in your higher level, most likely the statistician will suggest and highly recommended that you're going to do the random sampling technique instead of the non-random or non-probability sampling technique. So I hope the collection of data is very clear. So let's proceed with the next definition of statistics, and that is presentation of data. Of course, after you gathered everything, you collect the data, then the best way to give some picture about what you have collected is through the use of presentation of it, or presentation of data. We have common charts or organization or any forms of presentation, and these are what we call line graph, pie graph, bar graph, and pictograph. Next is the analysis of data. So if ever you already collected, retrieved your data, then you can now start to analyze it. Example, from the given data you collected, 20 or 20% are male, while 80 or 80% are female. So you just simply analyze all the collected data. Then after that, if you're going to put it in a conclusion way, we call it as interpretation of data, which means we can tell that majority of the respondents are female because 80 or 80% are female. Okay, sounds like that. That is what we call interpretation of data. And the interpretation of data use statistical tools, which will be discussed on the next slides. Now, what I am trying to share is about the actual survey questionnaire. Why I choose this? Simply because this is mathematics, this is about quantity, this is about computation. So instead of dealing with qualitative, we're going to deal with the quantitative research type of research. And we know the best tools to be implemented and administered is the use of an indirect method, or what we call a survey questionnaire. And the survey questionnaire looks like this. It has two or more parts. The part one is about the demographic profile of your respondents. So let us now consider this research. The effect of online learning on communication between instructors and students during COVID-19 pandemic. So in a given title of your research, it should compose at least an independent and dependent variable. The independent here is the effect of online learning, and the dependent is the communication between instructors and students. Example, does the online learning affects on the communication between instructor and students? That's what we call in independent and dependent variable. So, as I told you earlier, in doing the statistics, the very myth is the use of the data, which are can be expressed in the measurement level of scale. And these are now the content of your part one, the demographic profile. So we know most of the time name is optional for confidentiality. Okay, so how about sex? So sex is labeled as the nominal scale. Why is it nominal? Because you just simply classified, categorized the data as male and female. Another example of nominal scale or data are the citizenship of your respondent, Filipino, foreigner, and so on. The color of the hair, blue, black, yellow, and so on and so forth. The civil status, married, single, widow, widower. So the data are just classified or categorized. That is the nominal level, which is the lowest scale or measurement among the other measurements of data. So how about year level? So we categorize first year, we categorize second year as sophomore, third year, junior, and so on and so forth. So they are categorized at the same time were ranked. Okay, we know that fourth year is higher than first year. So we call it as ordinal level. Okay, so another example is the educational attainment of your parents. Another example for that is your position in the office. That are some of the common example. Okay, so that is ordinal. Next, monthly expenses 0 to 500 pesos, 501 to 1,000 pesos, or 1,001 pesos and above. This is an example of an interval scale or data. Zero here is arbitrary because maybe they have different meaning. So it is possible, yes, maybe he or she has provided by someone. So possible zero expenses about the load will be his or her answer. So what else? IQ test. If you take the exam and then the result turns that you have zero IQ test, the zero IQ test there doesn't mean that you don't have any knowledge at all. Maybe some factors as you're not prepared, you answer the IQ test not serious, maybe you don't really want to take the exam. Another example is the temperature. When the temperature reaches 0 degrees Celsius, it doesn't mean that there is no temperature at all. In fact, that 0 degrees Celsius is very cold. Meaning to say, under the interval data or scale, the zero value there is an arbitrary, which means it takes different meanings depending on the given situation. How about the age? Age is labeled as ratio. Why? Because 18 years old, 19 years old, 20 years old, 21 years old, and above are definite, are absolute. So the value of zero here is absolute. What other example is the weight of the newborn baby? Another example is the score in a given test or exam is part of the ratio. These four measurement of level or scale are very important in conducting the research. In fact, they are being used in order to do the statistical tools. Now, in part 1, we're going to use them and present them as example. 20% or 20 are male, 80% or 80 are female. We're going to present it that way. We call it as frequency and percentage distribution. On the part B question, we're going to identify what platform are most used during the online class. So in our NDMC, it is obviously that we are using the Schoology as our platform. So how are we going to present it? We're going to present it using the frequency and rank distribution. Why rank? Because we're going to rank it as first, which is the most online platform used. Okay, so these are the part 1. Let us now go deeper about the different scale. In doing the statistical tools, there are two terms to be considered. It's either to compare the means or the sample or to do the testing of relationships. What do I mean? If we're going to compare the two groups through their means, we call it as parametric using the interval and ratio level. If we're going to compare the rank of each ordinal data, we call it as non-parametric. We're going to know the significant difference or to compare the mean scores of those students who take the face-to-face as compared to those students who take the online class. This is what we call the parametric test because we're going to use the interval or ratio scale. In parametric tests, the common tests being used are z-test, t-test, ANOVA, or the analysis of variance. When we say independent samples, if we're going to compare two or more samples, that is what we call independent. But if we're going to compare the present and before data of this same sample, example, the pre-test compared to the post-test with the same group, we call it as dependent. But if we're going to compare the pre-test of those students who took the online class, while against to the pre-test for those students who took the face-to-face class, then that is what we call the independent samples. Again, take note this, if we're going to compare the mean of exactly two scores, example, the pre-test of the online and the pre-test of the face-to-face, we call it as t-tests. But if we're going to do the comparison of three or more, example, the pre-test of online, the pre-test of face-to-face, the pre-test using modality, then we call it as analysis of variance or ANOVA. But if we're going to use the ordinal data such as the year level and so on and so forth, the best statistical tools to be used is what we call a non-parametric test. And the non-parametric tests are Mann-Whitney, Kruskal-Wallis. So in parametric tests, the equivalent of t-test is Mann-Whitney. In short, you're going to compare the two ranks of the given data. In parametric, the analysis of variance, we're comparing three or more means of the given data. In the Kruskal-Wallis, you're going to compare three or more ordinal data. So in short, if we're going to take the ordinal data, that is for non-parametric. If we're going to take interval or ratio level of data, we are going to use the parametric tests. Now, the equivalent for t-test dependent is the Wilcoxon sign rank test. So simply, you're just going to compare the rank of the same data. Maybe the pre-test and the post-test of the same data. In t-test of dependent sample, you're going to compare the mean score of the pre-test and the post-test. That is what we call the t-test of dependent sample. So as long as we know the given data. So interval and ratio for parametric, ordinal is for non-parametric. Now, how about if we're going to use the nominal? So in this case, we're going to do the second statistical tools, and that is testing relationships. So if we're going to use the nominal, we're going to use a non-parametric, we call it as chi-square. If we're going to use the relationship, test of relationship under the ordinal, we call it as Spearman rho. Okay, what do I mean of that? Example, if we're going to state that there is a significant relationship between the sex and the IQ test score, then that is nominal because we're going to compare the male and female. So again, if we're going to use the nominal data to give the relationship to the IQ test, that is what we call chi-square. If we're going to use the year level has a relationship with the IQ test. Example, the fourth year has a highest IQ test than to the other years, first year, second year, third year. We call it as Spearman rho. But if we're going to use this relationship using the parametric, we call it as person R correlation test. So, part 2 na tayo, and this is about the perceived effects, which is specifically answers from the respondents. Okay, it's probably his ideas, his experience, his perception about each question. So as you can see, we have the table, so row and column. We have strongly agree, agree, disagree, strongly disagree. So most of the time, in part 2, presented in this way. So how do you call with that strongly agree, agree, disagree, strongly agree? We call it as Likert scale. And that Likert scale will tell us what will be the answers of each respondent. So example number 1, my subject's instructor explained well the topic. Then one of the respondents answered agree, possible, strongly agree, disagree, strongly disagree. The next is my subject instructor is approachable, strongly agree, disagree, and so on and so forth. So we're going to use all these checklists will be part of our data, and we're going to apply statistical tools in order for us to do some conclusion out of these answers. So example, if you want to use the mean and standard deviation, then we can tell among the 11 question, what is the most answered, or what will be the highest mean among the 11 question. Example, we have 3.91 on the number 2 question. Then we can tell that if the instructor is approachable, then it will affect the learning on communication towards their instructor. Okay, so actually this is the picture of the what we call survey questionnaire. So I hope you have at least have an idea on what is really important terms or details when we are conducting a research. And the research is nothing without the use of statistics.